Welcome everyone. We're waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the process of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. Few reminders before starting. Note that today's webinar we're targeting 60-minute session. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you may have additional questions post the event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We always love to hear your feedback on how we can improve these webinars. You can do so at aka.ms/security-webinar-feedback. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. While you are there, please join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews. Sign up at aka.ms/security-private-preview. While you're there, you can request features, give feedback, review our product roadmaps, attend in-person events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic to cover today. Ofer Shazaf is back with us today, and who will take us through correlation rules with Azure Sentinel. Ofer is a principal product manager of Azure Sentinel with deep expertise on this topic. And without further ado, I'll turn it over to him. Ofer, the floor is yours.
Thank you, Valon, and thank you everyone for joining. As Valon mentioned, we'll talk about correlation rules today. Before joining Microsoft, I spent many years at ArcSight. A correlation rule is actually an ArcSight term. We call it alert rule or analytics in Sentinel. And as you'll hear today, what I'll try to do is to make it easier for people who are accustomed to writing rules in other SIEM products to do the same in Sentinel. I'll start with showing how to do the same things. I'll try to go further and show you how to do advanced stuff in Sentinel, which would be hard to do in traditional real-time correlation SIEM products. The webinar today is planned for 60 minutes. I don't want to rush. It's a deep and sometimes more complex topic. If I'll make sure there's value for you if you can stay just for 60 minutes. I may continue further with some advanced topics that will be available in the recording later on. Also, because the topic is deep, I do expect that you'll have questions. Feel free to ask them in the chat window, but the answer may not fit a blur back, might require more. So we'll get back to you later. And also asking and discussing those topics on the tech community, which Valon mentioned, is probably the best idea to really get support. You'll want to share rule parts, queries, etc. This webinar is part of a series of webinars in which we try to make it easier for you to use Azure Sentinel. We already had a large number of them, and thank you for Ryan and Valon for organizing all those. They are available today, so you can go through them. Things like features of functionality, learning about the product, how you implement it, cloud and on-prem architecture, how you actually use it, incident response, threat hunting, or being an analyst in a SOC. Are all areas that we already covered. After today's correlation rule webinar, we'll go on to talk a lot about additional ways to use the product. Kara will talk about tackling identity, so identity-based use cases implementation in Sentinel next week. We'll recap our announcements for RSA after the RSA conference early March, and we'll talk about automation and threat intelligence in the coming weeks in March, automation being our SOAR engine, and on and on. I think that by tuning in, you'll learn a lot, both on Sentinel and on the SIEM world in general. The agenda for today, roughly split in two. We'll have an overview on rules, alerts, and incidents in Sentinel. It's a prerequisite to understand how to write rules. So we'll discuss what are alerts versus incidents, a core concept in Sentinel. We'll talk about rule scheduling, about alert entities, so the entities associated with an alert rule, and then a specific topic called Microsoft rules, which are a specific feature we have for handling alerts from Microsoft products. After this general topic, we'll go into the details of writing rules. And as you can see, I split them roughly around traditional SIEM terminology. Filter rules, correlation, aggregation, and then getting into more advanced areas such as behavioral analytic rules and lookups. Without further ado, I'll start. So, alerts, alert workflow, and incidents in the Sentinel world. Today, we'll discuss a lot a scheduled rule, marked here in, well, olive color in the middle. Scheduled rules are used to consume or query events or alerts. Alerts, like events, are stored in our data store. It processes them. We'll see today how. That's the core of the presentation. And it creates an alert. An alert is an immutable object. It doesn't have a state. It's there. An alert can optionally, it's a setting you set up in the scheduled rule, create an incident. It doesn't have to. If you don't create an incident, this alert is a notable happening. In the Splunk terminology, a notable event can be used later on, can activate a playbook, so run an automation script, but is not presented in the incident view for analysts to review. If you do select, so in most cases it does happen, you do create an incident. An incident is a mechanism to track and manage the alert. It has an owner, it has a state, it has comments, it has artifacts. We discussed all those in the last webinar about a day in the life of a SOC analyst. Now, this is what you'll see today in Sentinel. Things are getting a bit more complicated. We're already previewing and hope to have it soon, before RSA, an aggregation feature that will enable you to aggregate multiple alerts into a single incident. So if multiple alerts are just the same, they don't mean a new story, they can be bundled into the same incident. This is, of course, important in this context because it means that an incident is not anymore a single alert, but be more than one, still one owner. Next, very importantly, we'll learn about schedule alerts. I'll mention it as we go into the details. Schedule alert runs on a time period. It might have few results, few happenings. I'm trying to use a different term than alert or incident. For example, it might detect several brute forces on different machines in the same time frame. Very shortly, those will be at the choice of the rule creator, either a single alert or multiple alerts. So adding another level of capability, which adds complexity. A very asked for capability that makes, as you can see, this diagram more complex. Lastly, because an alert would not be an incident, there's not one-to-one, we'll also enable you to run automation on an incident, not just when an alert happens. Scheduled rule alerts, which we'll discuss in length in this presentation, are not the only type of alert that we have. And I do have a typo in the slide. I'll fix it before we share it. Scheduled rules in the middle is the wrong term. We have other types of alerts, which are triggered not by a scheduled rule that we provide you out of the box or that you created. And they are listed here on the left. The first one is a Microsoft alert. Microsoft alert implies an alert that we received from a Microsoft security product, such as Microsoft Defender ATP or Microsoft Cloud App Security. And it's already an alert. We don't need a rule for that. And here, sorry for the mistake in the middle, we have a Microsoft rule that would create an incident out of this alert. So you don't have to write your own rule. The Microsoft rule, as we'll see later, enables you to do filtering, etc., but you don't have to write a rule for that because it's already an alert. The same applies for a machine learning models. We have machine learning models in the product, and those machine learning models create alerts and then incidents directly. There is no rule you have to write around that. And lastly, not in this slide, because of the typo I mentioned, we have fusion rules, which will automatically, without you doing anything, will combine Microsoft alerts and in the near future also events to create an incident, again, without you having to write or deploy a scheduled query rule. So that's important. One thing that's missing today with all those without rule created incidents is that there's no way to run a playbook on those. And this is coming with the ability to run playbooks also in incidents. So that will enable running playbooks on every type of detection rather than just on scheduled rules. Again, apologies for the error in this slide where the two middle boxes have the wrong text. My cut and paste mistake. So let's go back to scheduled rules. The SIEM world is divided into two camps, so to speak. Older, as a fact, there are older SIEM products, such as ArcSight or QRadar, use real-time correlation, where when event is received, it's inspected and acted upon, which requires a special kind of handling to remember old events. How do you correlate the current event with something that happened before? And those systems have a mechanism for that, which I'll not go into today. Other SIEMs, search-based SIEMs, Splunk and Sentinel are two good examples of that, are based on queries that you run periodically. And those queries generate the alerts. We'll talk about this today, and we'll spend quite a time translating for those people more accustomed for real-time based correlations. How do you do the same thing and more using scheduled alert rules? But the first thing we'll have to touch on is that when you use scheduled alert rules, you naturally have to schedule them. So let's talk about the scheduling for a second. If you look at the right towards the middle, there are two important settings that you'll have to set for a scheduled alert rule. The first one would be the run query every, or the frequency in which a rule is run. Today, the minimum you can have with Sentinel is 5 minutes. We understand that you may want sometimes a higher frequency, and we are working on that. We do not guarantee the first run. So when you activate a rule, it will run as soon as possible. We do guarantee an exact frequency. So once the first one ran, say at the time here where I'm here is 6:17 p.m. in a few seconds, the next one will be in 6:22 p.m. in a few seconds exactly. That's one of the guarantees we provide. If you want to enforce an exact time, you can do it as part of the query by adding a time-based criteria that would include something like a start of day or similar function to make sure that the query itself runs on an exact time boundaries. So say 6:20 and 6:25 rather than the inaccurate times I mentioned. The second number that you'll have to provide is the lookup data from the last X minutes, days, hours. That's the how far back the rule can look into. Now, a simple rule, when we looked into that, will have a similar lookup and frequency times, as the example here, 5 minutes and 5 minutes, which works very nicely for filter rules, where you essentially want to identify specific events that should be alerted on. When you have a more advanced rule, such as correlation, aggregation, behavioral rule, the lookup data from last parameter is the maximum look back that the rule can have. Within the rule itself, as we'll see later on, you still can specify timeframes, which are very important for security rules, and we'll see a lot of examples for that. But it's the maximum. So if your query looks a day back, the lookup data from the last has to be at least a day. But if it's more, it's not a mistake. Lastly, there's another element here which talks about needs to set as part of the rule definition, which is the alert threshold. How many query results would imply a match? The best practice for us is to keep that always as is greater than 0 and make sure that the alert rule itself does the right job and identify would return 0 if there is no if you don't want to alert. So you'll not do brute force by searching for something and getting 5x results and then checking if it's greater than 5. You rather do a rule that anything above 0 would be an alert, and we'll see how to do that. You can use this feature. I think that once you know how to write queries for alert rules, you'll find it's more convenient to manage that within the rule itself. Let's look at the actual wizard used to write a rule, including the scheduling part we just discussed. So you start in the analytics screen, and you look for potentially a rule that already exists, one of the built-in rules, and then you can activate it. That does not require writing a rule, but might be your first choice. No need to write something if it exists. If you go to the built-in rules, you'll see that they are complex. You don't want to recreate those. Our research team is doing their job, and if it's there, it's advanced, maintained, and probably better than what you have time to spend on a rule. If not, you can go and create your own schedule query rule or Microsoft Instant Creation rule, which is the second type I mentioned earlier on, where we handle specifically Microsoft alerts in a simpler manner. We'll see that in a few minutes. So we are creating a schedule query rule. The first step would be to define meta information about it. This is used by the analyst in order to have more information about the rule. Description is presented to the user, the name, the tactic, etc., and the base severity would be taken from here. In the second step, we have to write the rule. Okay, we use a query editor. It has IntelliSense to create the query. And while the examples you see in the built-in queries are pretty complex, an initial simple query rule can be a one-liner, as in this example. Security event where event ID equals 1102, that would be our first example when we get to rules, is a very common filter rule. I just want to know if somebody cleared the log on a Windows computer, which implies trying to evade detection. The second line here, extend account custom entity equals account, is part of our ability to do entity mapping, which we'll discuss in a few seconds. So that's all you have to do. When you want to do more complex rules, and we'll discuss that in length in the coming minutes, the query here becomes more advanced. Next, you'll do scheduling, which we discussed in length a minute ago. And lastly, you'll be able to define the automation to run once the alert triggers. We find that because running automations using logic applications, our automation engine is very, very straightforward with Sentinel. Users often developed the automation and the playbook as part of the use case initially rather than afterthought later on. Two topics before we get to rules. I mentioned entities. When you define a rule, you define entities. We currently have 4 entities which you can define for a rule. It's important because those entities become an artifact, something that you see immediately when you investigate the generated alert. So those entities are important. They're also very important for our graph-based investigation, which we have presented many times in the past. It is entity-based. Those entities are driving it. The graph-based investigation finds relations between alerts, and it's based on entities. While you define entity as a single value out of the query, if there are multiple results to the query used to create the alert, those will be aggregated into a list. So, and that's why you have a number here. You may have more than one account as an entity of an alert, and host and IP, etc. As I mentioned before, entities are, while there's a UI, which you can see on the right, bottom right, to define those entities, it's just a shortcut for including the right element in the query. Actually, you define entities in the rule by extending, which is the query language way of assigning a value to a result column. So account custom entity would be the value you have to populate in order to have an account entity in your result set. So that's done for you, but if you create a query outside of this tool, for example, to implement it using the API, you'll be able to do it just by writing the right query element. Lastly, before we get into rules, Microsoft rules. Microsoft rules are a simple way to ensure that if you get alerts, which are already alerts from Microsoft sources, they're elevated automatically to be an incident without you needing to write a rule or a full-blown rule. It has advantages. You don't have to write a query for each source alert because the name of the source alert will become the name of the incident. It also doesn't have the challenge that if there are multiple results over one scheduling period, they'll appear as a single incident. And it maps more than the form entities that you can map in a scheduled alert rule, because being a Microsoft alert, we know the full schema of the alert, and we can map all the entities in it to our internal representation, which enables a richer investigation experience. On the other hand, there are limitations. It's not a full-blown rule. No playbooks, I mentioned that. No custom entity mapping, and the filters are pretty rudimentary. It's not everything you can do with a query language. Over time, we believe that the advantages above are going to all be available also in scheduled rules, and therefore this would be a simple way to create an incident based on a Microsoft alert, but you'll always be able to use a full-blown scheduled rule if you need more flexibility. So after we learned a bit about how you define rules, you create a rule, you define the scheduling and the query. Let's look into the actual queries and how to create them. You've already seen that before, but it's important to learn that the language we use, the query language we use, it's called KQL, which stands for Cousteau Query Language. Now you can Google for Cousteau and learn what that is. Interesting story behind that. It might be new to you. If it's new to you, of course, it's more challenging, of course, to write rules for Sentinel as well as to understand the webinar today. It is similar in many ways. On the one hand to SQL, on the other hand to say Splunk query language. So I hope that if you have some experience in those, you'll find that understandable, even if not writable today. In any case, if you're planning to write your own rules, I do suggest that you learn a bit more about KQL. There's a wonderful Pluralsight course that I'll provide a link as part of the presentation too, and it's free, that you can use to learn a lot more about KQL. And while the opposite order, we are considering having a webinar on KQL more in the context of Sentinel as well. But today we'll use KQL, a query language, in order to learn how to write the rules. I hope that I'll make it understandable also if you are not experienced with KQL. The first rule we look at is a rule that actually is one of our built-in rules. and it's the same one that I used in the previous slides, is the rule that will alert if somebody cleared the log on a Windows computer. Now, actually, we have a bug which I reported now we should fix in the rule definition. In a simple filter rule, the scheduling timeframes are enough, and you don't have to specify again any time within the rule itself. So the fragment here where time generated is more than a go 1 day. So search over the last day is not needed, because if you schedule it to look back for a day, that will be exactly what would happen. So no need for that. If it's just a filter rule, if it just identifies an event and alerts on that, don't include time in your query. It's just unneeded complication. The filter expression is the main part here. As you saw, a shorter version of that is what I used in previous slides. It's very simple. That's all you really need. Nothing more than that. Event ID and event source name. I actually used event ID before, which would create a few false positives, not many. The rest is important, and it's something that's overlooked a lot. The results of the query will be available to the user, to the analyst investigating the alert. And it's the job of the rule to prepare those results. And the two lines here, which uses summarize, so an aggregation function, counting, etc., as well as extend, which in this case define the entities, are important to prepare the information for the analyst so that the columns, the results of the query would be useful. In practice, if you have seen my previous webinar, it means that when the user goes to the artifacts part of the incident, press events, you'll get the results of this query at the right time frame. So exactly the information that created the alert. And to make the results more useful, formatting them here, selecting the right data, aggregating the right data is very helpful. As I mentioned before, and that's important, when you run this rule today, okay, if you had 3 clear log events in the same scheduling period, you'll get a single alert that will be translated in a single incident, but this alert will have 3 computer names as its entities. So analysts will get just 1 alert, but we'll see that there are 3 affected computers. It might be the right thing for your SOC. It might be according to the process in your SOC. However, as I mentioned, we are introducing an option that will enable you to split it into 3 alerts. So it's separate. So it's not a single alert, and that it's 3 different investigation areas for the investigator. So that's a simple rule. Creating simple rules is very easy. In practice, in a real SOC, my experience, I've been doing SIEM for a while now, a lot of the rules are just that. Let's talk about correlation rules, the more complex rules that you may want to have. And using an example, the user added and deleted rule, which is a very common one. It's a known attacker pattern. I wonder, being so known, whether it really happens, but you still need to detect for it in case somebody does it. The idea is that somebody added a user, most probably a an elevated user, some way to elevate privileges, and then shortly after, the user is deleted to remove evidence. It usually means that log files are harder to understand. The user does not show up anywhere. It's a very common way to do evasion. You'll notice that the way to detect that is to correlate. You need a user added event, let's call it the initiating event of the incident, and a user deleted event, which will be the triggering event. Once the user deleted, it's a real occurrence. It's a classical correlation event. Correlation rule. How do you implement this in Sentinel? So step 1, we'll have to talk about timeframes. We'll take a time frame of 10 minutes as the frequency to run the rule. We run it every 10 minutes. Okay, it can be lower, more. That depends on how frequently do we want to see these things. And it's similar to the scheduled rule frequency. Then we have the look back time frame. The look back time frame would be how far back this short time frame between add and delete, how long can it be? And we'll use 1 day here. It can be shorter or longer depending on your security definition. By the way, this rule is a real rule that we have in our library, so those numbers are the numbers we have selected. Next, we'll have a filter on the initiating rule. So the account was created event. In Sentinel, in KQL, we use a lot the let statement to make things more readable. Instead of using a long query that includes everything in, we use let to subdivide the parts. So account created would be all the account created events that are relevant for us. Then we have filtering. That's similar to the simple rule. Whatever are the events we want to have selected, user account was created in this case. And then the preparation, the result preparation. There is a specific, unlike the result preparation in the filter rule, here it has another reason. You'll see in a minute that this is just one of the filters. We have another filter for the delete event, and we need to match them, to correlate them, or to join them in the language of Sentinel. And in order to do that, we want both our user management events, they'll have the same field names. By using the project keyword and renaming the field, we actually have different names and making the correlation easier. So you can see here that the subject username is renamed to the account used to create, which is very convenient later on. Lastly, time. One of the key things you'll have to learn when writing correlation rules with Sentinel or any query-based technology is how to manage timeframes. And we'll talk about it a bit later, but keep in mind that here we are not looking at the lookback, a day back. We look at a day back plus 10 minutes, and that's important. Next, we'll have to look for the triggering event, the second event. Nothing very special here. We just look for a delete event. The one thing to keep in mind is that it does have to happen in the last 10 minutes. That's sort of a key anchor for making sure that we don't have duplicate events. A triggering event will happen just in the scheduling window. Lastly, we'll correlate them. You correlate in Sentinel using the join keyword. You join between the two result sets that we have. We have account created events on the left. We have account deleted events on the right. And we'll see if the same user was created and deleted on the same computer. That's essentially all the correlation is. Pretty simple. There are two things we add here. First of all, we ensure order. After we have those join, which essentially creates a list of pairs of creates and deletes. If there's more than one, we check that actually the deletion is after the creation. Per my definition of the rule, that's important. Security-wise, maybe alerting on the opposite is also okay. And lastly, we'll talk about it later, we need to do a time window fix. Let's go to the next slide to look into that. So handling a time window, probably the one thing you really have to learn. The rest was just filtering the first event, filtering the second event, and then joining to see that they both happened to the same user and the same computer. The time window management is the trick that you have to learn once, and then we'll be able to use it across any correlation rule you do with Sentinel. So when they trigger the triggering event, the last event at the end, would have to be within the time frame, within the scheduled frequency of the rule, 10 minutes in our case. That ensures no duplicates, just one alert can be for every delete event in our case. Now, keep in mind that when I looked for 10 minutes, it can be a minute ago or 9 minutes ago. That means that the initiating event can be up to 24 hours plus 10 minutes ago, because if the triggering event happened 9 minutes ago, I can't just look for 24 hours. I'll miss instances in which the create was a day and 2 minutes ago, and the delete was 9 minutes ago. It's still less than for 24 hours, but without the fix I'm showing here, we'll miss those events. To make that true, to make sure I don't miss anything, I look back to the create event for 24 hours plus 10 minutes. So we are fine. Then I'll have to correct. Why? Because I may have a create event 24 hours and 10 minutes ago and a delete just a minute ago, and I want to be correct. I want to avoid duplicates. Therefore, I'll correct by making sure that deletion and creation are not more than 24 hours away. So by applying this simple fix to the time, where closes, I can ensure a time window management correctly. No duplicates, no missed events, and no more than 24 hours between the first and last event. Now, in practice, in real world, events can be delayed. So you may find that time generated is time the actual event was generated, but you may get it later. In the real world of SIEM, it takes time to the events to get to the SIEM. Sentinel itself does not delay things, but the pipelines we use often do. And it's true for collecting from on-prem, and it's true for collecting from the cloud as well. For example, Windows firewall events are collected every few minutes by definition by our agent. They're actually written, I think, by Windows every few minutes. So how do you handle delayed events? And that's actually a very interesting thing, because delayed events are very hard to handle in real-time correlations. When you get the event, the relevant event around it are all already have been processed, they are past history. So there's nearly no way around it. But in query-based SIEMs, actually there is a pretty easy method for that. So I'll use the same example. I'll add a fix for delay. So if in the previous example I searched for the triggering event in the time frame, now I'll look at the time frame plus delay, say up to an hour. So let's look for the delete event for last hour and 10 minutes. Now, we do need to make sure that it was ingested now in the last 10 minutes. That's the only way to ensure there's no duplication. So we'll qualify that. It have been generated up to an hour and 10 minutes ago, but we'll use a special function available as part of queries, the ingestion time. When did it actually arrive to Sentinel? And we make sure that happened in the last 10 minutes. So now we will cover for delayed events up to an hour or as much as you want, but we'll make sure that we alert only if they arrive now, which means that we'll not have duplicates or missings. We'll, of course, have to have the same delay factor for the time for the initiating event. And lastly, we'll do the same check that there's no 24 hours between them. So by adding a very small fix, one more variable to the same query, we're able to have this query and every query compensate for delay of arbitrary length. I think it's a very major advantage of using Sentinel versus real-time correlation. Let's move on to aggregation rules. Correlation was when we matched one event to another. This is usually done by correlation in traditional SIEMs. There's a feature that looks roughly the same as the Sentinel rule. It's written differently and it is implemented very differently, but the rules look roughly the same. In this example, we'll do something which is pretty hard to do in traditional SIEM because it combines actually aggregation and correlation. Which in traditional SIEM usually involves going into a concept called active list or reference sets, and we don't really need them here. I'll use a brute force example and use a very interesting brute force example. Again, one which is available in in Sentinel. We'll check if there are multiple failures on Azure, so if from the same IP address there are a lot of failures on Azure, but a success on AWS. It's a great example of the strength of a SIEM. Also shows you that Sentinel is not just Microsoft. We collect from AWS and can do across. In this example, I did not. We did not consider the order important. So the Amazon success can be anywhere in the middle, which is important. What we'll do is we need to count number of failed logins, make sure it's over a threshold, and we see if there is a fail event on success event on AWS. How does it look like? So the first one will be the aggregate initiating event in the terminology I used before. We'll use a threshold of 5, and it's not really very promising to use a fixed threshold. Just in a few minutes, I'll show you how to make the threshold behavioral, which I think is a great thing. But here, let's start with a fixed threshold. We'll filter for the relevant events, whatever are failed logins in the AAD sign-in logs. We'll summarize by IP address. So now we have the result of a summarize function is not anymore a list of filtered events, but rather a table of IP addresses and counts. So we know how many counts are, how many failures were for each IP address. We'll qualify that and see how many are over the threshold. And then the trick is that we'll create a list of those IP addresses. All we need for the reminder of the rule is just a list of the offending IP addresses, those on which there were a lot of failures on Azure. If we don't want to have if we just want an aggregation rule, we just remove the end, we finish the summarize count, and we have an aggregation rule. We'll continue with aggregation and correlation, and we look into the triggering event, the second part, the AWS success. It's actually very simple. We filter on the trigger event. It's trigger on the AWS event stream. You'll notice that events getting from AWS tend to be more complex, and we use query time parsing to get what we need out of it. And then we check for the condition. And the condition is very simple. We had a list of suspicious IPs, and we just check if the AWS login is from a suspicious IP. Very simple, nothing here. Again, in the ArcSight world, that would be updating an active list when the failure events get, doing a count, having a second rule for AWS, and looking up in the active list. So much easier. Keep in mind that I did not have any time window management here because I made a decision that order is not important. If I would wanted the order, I had to add drafted the same time management I had in the previous example. Now, I used a simple threshold 5 for that matter, which if you look into most SIEM rules, they usually do that. Let's see how to do a behavioral threshold in Sentinel. It's so easy that you can just always do it. Amazingly, close to you. So it's the same filter, the same sign-in logs. I'm now filtering for 7 days. I use start of day and end of day because when doing baselining, I prefer exact days rather than whenever the rule runs from 7 a.m. to 7 a.m. the next day. It might not be needed. It's a security researcher's decision whether to do it. Then I do, and here my behavioral set was that I essentially bucketized. I created a list of counts per IP address per day. So I have a long list. The result of the summarize here is a long list of failure counts for IP addresses and days. 7 days, how many IP addresses in your environment? You have a long list of those. And then I use a statistical function. In this case, I assume normal distribution. So I used average and standard deviation, and I decided the threshold would be one standard deviation above the average. And it's the same threshold. I mean, I just use it, I assign it in the first line to the sign-in threshold. The rest of the rule doesn't change. But now the sign-in threshold is behavioral and not fixed. Nothing more. Want something else? Probably. My guess is that sign-in failures are not really normal distribution. There's a good chance they're Poissonian distribution. So I'll use percentile. It's another option. The set of options available to you in Sentinel using KQL is amazing. Any analytic function you want will be as easy to imply here. So if you want to move from your traditional, fixed threshold based into behavioral, you got it here. Now, we covered a lot. The next topic is not short. It will not take 10 minutes. I'll start with it. Valon, do you want to break for question for me to, at the hour mark, to get back to that, or do you want me just to continue? What do you think would be preferable?
Please continue over, because most of the questions we answered already, so we're good on that one. And if we go a bit over, should be fine.
Okay, great. Good idea. So we covered simple filter rules. We covered correlation rules. We covered aggregation rules. A major area where SIEM does a lot of work, a lot of rules are about it, are lookups. You want to look into external data sources in order to enhance the rule. And we look into 3 lookup use cases today. We'll look into whitelisting, when you want to suppress alerts for centered entities. It's very common that you want to fix false positives by having a list of users, not as part of a rule, stored somewhere in a file or a database, where you have those users that often trigger a specific rule. You may want to have a watch list, which is entities that you want to alert specifically on, most typically a VIP list. Those users that if are touched, well, or administrators, it's a higher priority. And the last one will be enriching. You want to add data to know more about entities in order to be able to detect. And we'll see examples of all of those. We'll start with using a lookup into an external file. And then we'll show also how to do it with other sources of data. So Sentinel has, or KQL has, a very convenient external data operator. We'll use it a lot here. It uses an external file that has to be accessible by a signature. So the security has to be embedded within the URL. And Azure Storage has a very convenient way to get an access signature that works very, very well with the external data feature. It works here for blob containers, for file shares, and actually also for tables. So for most options with Azure Storage. The way you work with the external operator is that it's essentially, if we looked into a KQL query before, it used to start with a table. I jumped over that, and then qualifiers. And here the table would not be an internal table and an event table within Sentinel. It will be coming from an external file. So here I have an external file operator. I sort of, in the middle, I have the signature, the URL. And you see the results. Note that you can select the format, and in this case, I select format as text, which means that the system took it to be just a series of one-line items, no parsing whatsoever, and that's why the username field, which I defined here, another typo here, the name should have been user principal name, should be the same. I probably took the screenshots from different systems, is all of the line, and you see the line in the file. We have a username, a user principal name, then a full name, a score. We'll see how I'll use the score later on, and some geographical information about the user. And we'll use this file throughout the examples in this lookup section. The external data operator has a lot of flexibility, more than I'll show here. For example, you can see that since most CSV files include the header in the first row, you can use an ignore first record option that will mean that the first line is ignored. How do we use that? So our first example was to whitelist users prone to failure. So we have a service account. The service account generate brute force because that's the nature of the beast, and we want to make sure that it does not trigger on this sign-in condition that we used earlier on in several examples. What we'll do, as you can see in the first line, is use external data. Again, a very good best practice is to use it as part of a let statement so that it's better documented. We did not use the type as text, so the extension I used for the file, which was a CSV, would be used. That means it would be automatically parsed in the field, the first field being, as you remember, the user principal name, which means that the result of this whitelist is a list of users, and then we'll just use it. All we have to do is add a where clause where user principal name is not in whitelist. As simple as that. Those two lines, the external data at the top and the where clause at the bottom, add to us a whitelist very simply. Watch list, not much more difficult, but it does show us the flexibility and strength of the way Sentinel does external lookups. So the idea here is that I want to use the same table, but now use the risk field there, and alert only if the sign-in failure is for risky users. So too many sign-in failures, you never want to alert on those. You just want to alert if there's a failure for administrators, for that matter. So you sign in a high risk. What we'll do here is there are a few differences. First of all, you'll see that I named more fields. Since it's a CSV, I can name not just the user principal name. Now I have all the fields in the example above as fields in my query. Secondly, I filtered the lookup table on high-risk users, which exemplifies a very important concept here. External data is a table. You can do it with everything you do with a Sentinel table. It's not a static CSV lookup that you can just use a lookup feature on. You can summarize it. You can join it. You can do everything. You can do statistics on the external data. So you can do you can use the external data to establish a statistical threshold. That's a very powerful capability that I think is unique to Sentinel. I might be wrong about that. Once we have those filtered users that are over 90, we do the same thing you saw before. Now we'll do the opposite. We'll make sure that the user is in the watch list rather than not in the whitelist. So I changed the name to make the use case clear. Enrich. I mentioned whitelisting, watch listing, and I'll provide an example of enriching. If you recall the input file that I used, the same input file was also included geographical information at the end, which is now mapped into the location field, which notice is a dynamic. Since the value was a JSON in the text file, and I map it to the dynamic, it would be automatically parsed from JSON. Now I will extract using extend the user country using location dot country, so it's available there. Again, external data is just available. I can do everything here. And now the simple in operator is not enough when I do enrichment. I'll use join, the same join we used earlier between two event tables when comparing whether the same user was added and deleted. I'm using here. I'll start with the failed sign-ins, okay? Whatever those were, whatever was the term for that. And then I'll join it on user principal name, okay, with the following condition. The condition is that the location as identified in the failed sign-ins is not equal to the user country registered for the user. What did I get here? An interesting detection. Now I alert on a sign-in failure, but only if the user is signing in internationally, not from where he is supposed to be living. So a very simple example of enrichment. I enriched the users with their uh, country of home country information and use that in a rule to reduce the number of alerts. It's a good time to remind you that a lot of the information here is not just available here in this webinar, it's also available in our blog posts, which for those who prefer reading to listening, might be more convenient. We also have upcoming blog posts. For example, we have an interesting use case where we are actually using HR information to check in which country the user is currently based on internal system, which in Microsoft we have, and then we can correlate out the known location of the users. Now, we talked about external data. External data is not the only way to get the lookup information. We have other methods. One of them is SQL request. SQL request will enable you to use exactly the same methodology, but using a SQL database, Azure SQL for that matter, which would enable you more flexibility. When we'll use the one or the other, depending on how you're going to manage the lookup data. On SQL, it's easier to build an application to review that, to edit that. The other thing which you'll have to consider, and will also lead us to our last example today, would be how you manage security. In both those examples, in SQL and in external data, the secret is stored in different forms within the query, which might not be secure enough. In the next example, we'll see how you can overcome this limitation. Probably the best way to overcome this limitation is to use a workspace table for lookup. So instead of using an external source, to actually import data into the workspace, into Sentinel, and use it for lookup. Sentinel has the advantage that first it has many ways to get information in, and the information does not have to be formatted in any certain way. So unlike a fixed schema sim, Ceph, Leaf, whatever, whatever you get in will be there and can be processed on the fly as part of the query. In this case, we are using probably the simplest way to upload data, which would be an available partial module that knows how to import data to the workspace. In this case, I pipelined into it a CSV file, and voila, I created a table, users lookup, which has the same structure as the external lookup that I did before. The one difference here is that when you import data to a log analytics workspace, it's by definition does not overwrite the information already available there. The reason for that is the data in the workspace, as you would expect from an event management system, is immutable. So the data that's already there in the table stays. So if you run this import every week, every day, you add to the data rather than replace it. The line below shows you how to handle it, how to mitigate the fact that there might be multiple records for each key. And the key is a summarized function called argmax, which is pseudo summarized. What it does, it gets you the latest, okay, the max, based on the first field in the parameter list of argmax. So here I use the same syntax, the same let whitelist, so the rest of the logic in what I did before does not change. I looked up in the user lookup CL table. It's a custom log table. The log type name you listed up above would be appended with _CL in the actual workspace. And then to fetch only the latest events for each user, the latest entry, sorry, for each user, I use summarize argmax by time generated, so the latest. Asterisk means get me just the whole field list and then by username. So I'll get for each username just the latest update for her or him. That will essentially create the same whitelist or watch list or enrichment list that I had before based on a file uploaded through a PowerShell command into the workspace. Very valuable alternative to the others with the advantage that there was no secret stored in a query in the workspace. So to summarize, we discussed today several important topics. What I wanted to achieve, and I hope I did, was to show you how to write rules using Azure Sentinel. I tried to go through a traditional set of capabilities you want to have in a SIEM, starting from a simple filter rule, going on to correlation and then aggregation. Actually, the example for aggregation was for a aggregation and correlation, which is even more complex. On the way, I did mention two specific capabilities that are very, very nice with easy, I would say, with Sentinel. One is how to handle delayed events, and the second one is how to create a behavioral threshold. And lastly, we discussed lookups, how to add lookup information, context information into your queries, either from external sources or from by uploading data to the workspace. Altogether, I hope that it was a it would be a very valuable method for you to start learning how to write rules in Sentinel and see the strength of it. It's a first step. As I mentioned, a lot of the information here is also summarized in blog posts in our tech community. Sometimes reading is easier. The blog posts are also a very good place to discuss those techniques. Also, if you want to learn more about our detections, go to the experts written detections, go to our GitHub. Our GitHub includes the complex stuff. Sometimes it's too complex because that's what our researchers are doing, but it's also a good example for best practices on writing rules, as well as examples for specific use cases you may want to enhance on. And lastly, any other question? If it's public, go to the community. You'll have more people answering. If you need us, the email below is the team answering questions around the table, and we'll make sure we go back to you. So I hope you've enjoyed and got value from the webinar. And with that, I'll get back to you, Valon.
Great, thank you. So just a few reminders before ending the call. Our next scheduled Azure Sentinel webinar is next Wednesday, that is February 19th, tackling identity with Sentinel. In the month of March, we also have two Azure Sentinel webinars in the pipeline. That is RSA recap, currently targeting March 4, and deep dive in threat intelligence targeting March 18. For details and registration, please go to aka.ms/security-webinars. In case we missed to answer your question, or if you have additional questions, as Ofer mentioned, you can visit us on our Azure Sentinel forum at aka.ms/Azure Sentinel community. And I want to thank all of those who helped answering the questions. Thank you, Ofer, for another fantastic presentation. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.